Hello, everyone. There was this question in the Phoenix forum recently. A client was asking what are the best options to create this type of setup, where you have a pool of water spilling over an edge and lending into a water that sits at a lower level. Normally, when you build something like this, you'll need a huge simulation grid. And if you want to have a decent resolution, you'll have to deal with a lot of voxels, and most of it will remain empty. For a situation like this one, Phoenix has a really convenient tool called cascading simulators. In this video, I'll demonstrate some techniques of using this handy feature. Here is a scene where I have two simple geometry objects, one for the fountain bowl and a simple box for the floor. I used a box, not a plane, because whenever you have objects interacting with Phoenix simulations, they need to be solid objects with no open edges. There's also a single dome light and a camera, but let's hide these two for now so they don't get in the way. Further down, I have the three separate simulators that I'm going to simulate in sequence, one after another. They are called Cascade 1, 2, and 3. There's also a couple of layers where I like to keep all of the components needed for each simulation. They are named accordingly so that it is easier for me to tell which objects are needed for which simulation. That way I can easily switch between the components needed for each particular one. Let's hide everything and leave only the layer that holds the components needed for the first simulation. In this case, it's just a simple emitter object that I made by selecting the bottom and inner side faces of the original bowl, duplicated it, and closed the top. There's no need to create a Phoenix source. Instead, I'll use the initial liquid fill-up option available in the Phoenix properties. Right-click on the object, select Chaos Phoenix Object Properties, make the object non-solid, and enable the initial liquid fill option. This way, the object will be instantly filled with liquid particles. You can enable display as box mode for it in order to see better what is happening on the inside. I made the first simulator big enough to encompass the whole emitter. That makes it the largest one of the three, but we'll need to simulate just one single frame. Go into the simulation rollout. Disable the checkbox that makes the simulation length to be based on your timeline. And since the timeline starts at frame 0, make the simulation end in that one frame. The rest of the settings are not really important here, so you can leave everything at their default values. You can just choose the resolution you want and press Start. After that one frame is simulated, you need to make it present throughout the whole animation. Go into the input rollout and enable the Load Nearest If Missing checkbox. Doing this will force Phoenix to load this single cache file in all of the missing 200 frames. That way, there is no need to simulate pre-roll frames and wait for the liquid to settle down. For the next simulation, I've prepared another simulation grid in advance in order to keep this video short. It is important that the two grids overlap a bit. Hide the layer that holds the emitter object for the first cascade. For this one, there is no need for any Phoenix sources or emitters. Simply go into the grid rollout, enable the Cascade Simulator checkbox, and pick the first cascade that will act as a source instead. You can start the simulation now, and the liquid particles in that one single cache file will start spilling into the second simulation grid. Great! Now that we have this working, it is only a matter of tweaking the dynamics options in order to achieve the result that you are after. Let me walk you through some of the settings that worked for me. First, I have the adaptive grid enabled and restricted the expansion so that the grid can grow based on its liquid's content, but only in -z direction. I limited the expansion so that the grid only expands to a certain point, just before it reaches the floor. Next, I had the foam generation enabled in the foam rollout and also the splashes and mist in the splash mist rollout. I had the thresholds and the amount tweaked to my liking. But most importantly, I've set the outside age for both foam and splashes and mist to 0. That way, they'll be killed immediately when they reach the grid's border. And also, you may have to reduce the affect liquid value to make sure that at least some of the liquid particles reach the bottom and overlap with the third cascade. When secondary particles generation is enabled, Phoenix creates containers to hold the particles' data. It is my preference to move these containers to a separate layer so that I can collapse them in the Scene Explorer view and know exactly where they are if I need them. I had the steps per frame set to 2 inside the Dynamics rollout, but really you can go with whatever suits your project. Inside the layer that holds the elements needed for this sim, I have a turbulence force that is added into a particle tuner in order to help me set some rules about where the force will be applied. The rule simply says, don't affect liquid that isn't moving or if it moves slowly. Start applying the force when the speed is above 20, and when the liquid starts falling down and builds up speed, stop affecting it and let it do its thing. For the turbulence force itself, I set it to affect only the liquids and not the foam and splash and mist particles. There is also an object called foam splash birth volume. It is a simple tube primitive that helps me define areas where I want the foam and splash particles to appear. I have this added in both foam and splash mist rollouts. You need to either set this object to non-solid in the Phoenix Properties dialog or simply hide it so that it doesn't affect the liquid's movement. And finally, there is a simple cylinder in the middle that is set to non-solid, but it has the clear inside option checked. This will get rid of some of the liquid towards the center, but leave the particles that are going over the edge. This one needs to remain visible in order to work. You can set it to be displayed as a box. That being said, you can still make Phoenix interact with hidden objects. You can use the scene interaction rollout and the include-exclude list that is there. But let's leave this for more complex setups. The default behavior works best in this case. Now that all the preparations are complete, let's start another simulation and check the results. The simulation has finished and the result looks good. You can inspect the cache file content window to see how many particles were created during the simulation. They seem like a proper amount, and displaying all of it inside the 3D Studio Max's viewport may slow things down a bit. That's why Phoenix has this handy auto reduction option inside the preview rollout. I had this previously disabled, so I'll go ahead and switch it back on. Alright, with that one done, now it's time to tackle the final cascade. Let's hide the layer that holds the elements we need for the previous one, since we don't need it anymore. Next, we'll make a grid that sits on the ground and is just high enough to overlap with the incoming liquid. Then, go into the grid rollout and enable the cascading simulator option. Pick the previous cascade to link it to the new one. And for this last one simulation, I'll use the initial fill-up option that is in the dynamics rollout. This will create some liquid right from the start. Since the simulator is not really that tall, we may need to raise the water level a bit. 65% sounds about right. Enabling the fill up for ocean option will create some pressure near the grid borders that will help the liquid to stay at that level and not spill to the sides. It's important to note that in order for the fill up for ocean option to work properly, all of the container walls need to be opened. And once again, you may need to adjust the secondary particles generation options. What I did is to raise the thresholds a bit and lower the amount of particles that were created. That took a few test sims, but in the end, I ended up with a manageable amount that looks good. You may also decide to turn the pattern formation speed up and play with the size and stringiness options to have a more realistic look. Adjust the resolution if you need to. It doesn't have to be the same as the other cascades. And when you are ready, press start and wait for it to finish. The sim is done. You may have noticed that I tweaked some of the settings, mainly the foam amount and birth threshold, as well as the pattern generation speed and size. I also increased the raising speed so that the foam rises up to the surface quicker, and that helped me with the patterns on one hand. The patterns only start to form when the particles rise to the surface of the water. So making it rise faster means that there will be more particles on the surface to begin with. And on the other hand, the higher rising speed also helped to keep the amount of foam particles lower, since I also lowered the half-life settings inside the lifespan section. This setting only affects foam bubbles that are already on the surface. Additionally, I created a particle tuner and placed it inside a new layer that holds the elements needed for the third cascade. The tuner uses some of the latest options added in the tuner's functionality. If you download a more recent nightly build, you'll notice a couple of new options: distance to particle and particles in radius, meaning that it is now possible to check a particle's surroundings for certain conditions. In this case, I'm checking if the distance to foam particles is greater than 0.05 centimeters, and if it is, the particle should be deleted. and this only affects the foam. In other words, if a foam particle separates from its friends too much, it gets deleted, and this will prevent having single foam bubbles floating around and might give you cleaner patterns with less noisy appearance. I've created 6 separate particle shader nodes, one for each particle group system, 2 shaders for the splash particles. Each one contains one of the 2 splash particle systems. The reason I didn't put the 2 in a single shader is because I wanted to link it to the 2 different liquid simulators. Choosing which simulator is used in each shader defines how the particles should be shaded based on the condition if they are inside the liquid volume or outside of it. Those 2 are set to render the particles as splashes. With the liquid simulator selected in the shader, the splashes rendering mode will render only the particles that are outside of the liquid volume, which is basically what we need. The splashes will refract light and have some specular reflections. You can adjust those settings based on the result that you are after using the available options. The next 2 shaders are for the mist particle systems. Like the last ones, each one is linked to its corresponding liquid simulator. These use the fog rendering mode. When set to fog mode, Phoenix will create a volume grid internally and will use the smoke shader for rendering. You can control the resolution of that grid by changing the fog voxel size option. In addition, you can control the fog density and the absorption color. And if you switch to the ray-traced scattering mode, you'll be able to use phase function to fine-tune the way light is scattered through the volume. And finally, there are 2 separate shaders for the foam, one for the particles coming from the second cascade, and one for the ones coming from the third one. Again, each one is linked to the corresponding simulator. Those 2 are set to render the particles as points. The points are flat disks that are 1 pixel big by default. Depending on your rendering resolution, they may appear more bright or more faint. You can control that by unchecking the Ignore Particle Size option and adjusting the size multiplier in the General Settings rollout. These points are still going to be rendered as 1 pixel wide flat disks by default, but they will appear more bright or more dim based on the size multiplier. You can also animate this value based on the particle age. To do that, you need to have the particle age channel enabled in the output rollout in the simulator. It is worth mentioning that in reality, the foam is made out of tiny bubbles, meaning that in small-scale simulations, you may want to choose rendering the foam in bubbles mode that is also available instead of points. This will give you a better-looking foam at the cost of rendering speed. However, when dealing with large-scale simulations and foam that is far away, the point mode will produce great results, and it will render significantly faster. One other thing that you may have noticed is that I made the third simulator grid more narrow and it is no longer reaching the right side of the frame. I did this because I wanted to iterate faster and have smaller cache files. If you want to extend the water surface beyond the simulator's borders, you can go into the rendering settings and switch the mode from mesh to ocean mesh. Phoenix will create an infinite water surface, and the ocean settings will become available. Here you can control the level of the surface. You'll have to match the height with the one that you set in the initial liquid fill-up. And the border fade percentage will help you blend them better. Since the sim resolution is not very high, the mesh may bulge a bit in places where the liquid particles are being meshed. In such cases, you can use the ISO surface level to adjust that. And one last thing, if you don't need the infinite ocean surface and you only want to extend the surface just to the edge of, let's say, a swimming pool, one way to do this is to create a VRay Clipper, set it to mesh mode, set the operation method to intersection, and choose a geometry that you made in advance. It can be a non-renderable box, cylinder, or any shape you want. You can use the include-exclude dialog to make it only clip the ocean surface. And that's pretty much it. Thank you for watching this tutorial. I hope that it was useful. Take care and see you next time.